Okay, so this is the third video of our playlist on the numericals of steam turbines or the applications of first law of thermodynamics. So this question states that 50 kg per second of steam at 70 kilopascals, 50 kg per second of steam at 70 kilopascals and 280 degrees Celsius is mixed with liquid at 40 degrees Celsius. It exits at 700 kilopascals and 200 degrees Celsius. What is the flow rate of liquid water? Assume that Q is 0 and shaft work is also 0. So if we see here that a flow rate of liquid of water, so in this question we will be using your material and energy balances, which is we will be using mass balance as well as energy balance. So in this question both are used, mass balance and energy balance. The diagram or the diagram for this question, if we make it, it is like you have steam entering at 700 kilopascals, which is equals to 7 bars and 280 degrees Celsius. And what is the flow rate? 50 kg per second, or flow rate of the steam is known. It is mixed with water at 40 degree Celsius. Okay, and let the flow rate be W kgs per second. What is the flow rate of liquid water? So we need to find out this. And here we are getting a mixture of which is at 7 bars and 200 degree Celsius. So we begin this question. So we begin this question by, the very first step is that you need to understand that superheated steam plus you have subcooled water. It is at 40 degrees Celsius. The Tsat of liquid water is 100 degrees Celsius. So this is your subcooled liquid or subcooled water. It is giving us a mixture which is at 200 degrees Celsius. Okay. So for if we see for the steam or S, for steam, if we calculate the value of H at 280 degrees Celsius by the interpolation method, we have values available at 300 and 250. I hope you know how to do the interpolation. Otherwise, drop the comments down below and I'll make a separate video on the interpolation method. We will find out at the value of enthalpy at 280 degrees Celsius, which comes out to be the value of H enthalpy 280 degrees Celsius, it is 30.16.9 kilojoules per kg. So this is your value of S or enthalpy of S. Now after that we will be finding out the value of enthalpy of the mixture. Mixture is at 7 bars, right? And its temperature is 200 degrees Celsius. So if at 7 bars we look at our steam tables and look for the saturation temperature, it is 164.97 degrees Celsius. Now we know that our given temperature is greater than Tsat, so it is also superheated steam. So what is the state of the mixture? It is also a superheated steam. It is a superheated steam. Then we will find out the value of H. It is directly given in our steam tables. It is given as 2844.8 kilojoules per kg. Now what is left is the value of enthalpy for water. Now how we will be finding out the enthalpy of water? Now at 7 bars, if we see at 7 bars, the saturation temperature is 164.97 degree Celsius. This is your saturation temperature. Okay. Now, and at 7 bars, if I in the saturated steam tables, if we look up for the HF value, it is given as 697 kilojoules per kg at 7 bars. This is the enthalpy of liquid water at 7 bars. Now we find out the enthalpy of water. It is enthalpy of liquid water minus Cp delta T, which is your for the specific heat for phase change. Now the value of Cp for water is 4.2 kilojoules per kg. It is 4.2 kilojoules per kg. So the HF for water is 697 minus Cp of water is 4.2. What is the delta T? It is the saturation temperature, which is 164.97 minus your 40 degrees Celsius, which is the temperature. So this comes out to be 6 approximately. This is around, like, whatever the value comes here. Now it is in the value of this is in the saturated water. Okay, now if we need to convert it to subcooled water, we will subtract 525 from the equation. If we quickly find out this value on our calc, it is what is the value? 697 minus 4.2 multiplied by 164.97 minus 40. Right, so we have this bracket, and yeah. So the value of this comes out to be 172.126 kilojoules per kg. So this is the value which comes out here. Then, so this is the enthalpy of water. After that, we need to calculate the enthalpy of vapors at 7 bars, which is of your mixture. Enthalpy of vapors at 7 bars, which are your vapors. So for that, HF plus X times HFG. For vapors, X is equals to 1. So at 7 bars, HF is given as 697.1, X is 1, and HFG from your saturated steam tables, its value is 2064.9. Then this comes out to be 2762 kilojoules per kg. So try to understand what we have done in this question. Firstly, we understood the question as the mixing of steam with water, and what we are getting is a mixture. We took out the state of the mixture is superheated. Superheated steam plus subcooled liquid we are getting as a mixture. Now we are calculating the values of enthalpies, because the flow rate we will be finding out from your energy balance equation. The values of enthalpy for steam at 280 degrees Celsius, for the mixture at 7 bars and 200 degrees Celsius, the value of enthalpy is so much. And for the liquid water, the value of enthalpy is this. The saturated, ये हमने saturation temperature निकाला. उसके बाद we had your enthalpy value at 7 bars, which is also saturation. Then हमारे पास जो specific heat को हमने उसमें से subtract कर दिया. So this value we get, and this is for your vapors at 7 bars. So now applying your material balance equations. For the material balance, it is 50 of the vapors plus water. It is giving us a mixture. This is your material balance. Then if we apply your energy balance equation here, for energy balance equation, it is 50 into the flow rate of steam plus W, which is the flow rate of water, into the enthalpy of water, 50 into enthalpy of steam, flow rate of water into enthalpy of water, multiplied by the flow rate of the mixture into the enthalpy of your mixture, right? So this is 50 multiplied by 30.1748 enthalpy of steam plus flow rate of water into enthalpy of water. What is the mixture? Mixture is the 50 plus W, right? This is the flow rate of mixture into the enthalpy of mixture. This. On solving this, we get W as 3.242 kilojoules per second. Okay. So this is the flow rate of water. Now, if you also want to find out the flow rate of mixture, it is 50 plus 3.242, which is 53.242 kilojoules per second. So this is your flow rate of mixture. This is your flow rate of water. So this is the answer to your question. So it is a easy question, but a bit tricky as well. So